Hello. Okay, sound. Cloud. I think this is the one that I was listening yesterday. No copyright. Playlists. That was the one that I was playing yesterday. Lo-fi beats. Is it too loud for you? Like compared to what I used to talk, I think the levels are kind of okay. Okay, fine. Yeah, let's put it maybe a little less louder. Yeah, kind of cool. Okay, let's begin. Hello, hello. Let's see how this is doing. Yo. Okay. Yeah, I think we are just live. Sorry, apologize for that. Okay, session is here about to begin. Okay, we are just live. Hello, these bots. Bots on Kick never leave me alone. So yeah, kind of sad. Not gonna lie. Okay, so I think I can close this one. What is going on Kick? Yeah, but I'm on live right now, so cool. And let's see, okay, on Twitch, how we are doing on Twitch. Okay, we are live. Nice. Hello, hello, welcome, welcome. So what was the thing that we were doing yesterday? Yesterday we were having some issues, as you know, because of my skill issues. So this time we are gonna try to build something visual, at least something that we can see visually, right? But I have to do a few adjustments according to the book. So the first thing that I have to do is I need to add yes, the graphics, the window, the system, but I also have to add sfml dash network, because apparently we are gonna use it. No, what is this? Let's go and network. I will add also sfml dash audio. And I think we are just ready to go. Oh, I would like to promote. Hold on, let's open x.com and Blue Sky, because I want to promote my streaming. So let me share this one real quick. Well, on X, yes. Just chilling and learning some C++ and SFML. So learning learning some C++, and SFML. Let's include this one, and I also would like to include my Twitch stream too. So could I, this is player, how could I share this stream together? Let's go to just and just no. Let's go to my channel, and this is the thing that I want to share. And this is the thing. Where is the post? Yes. Let's have some emojis. Where are my emojis? Like this one. Okay. So let's go and let's see if I can just go to machine learning C++ Twitter. This post here. Yeah. Okay, welcome. Now it is time to I want to post here, so here you go. Okay, let's begin. So I was doing yesterday this, so I have to go to CD, build, and inside here CMake that, and then I have to go back to the other thing, and then I just need to build the whole thing. And I have no idea where this is building it, but okay. I'm gonna update my repo just because I'm adding some modules, some required modules. Let's push this. So okay, find the additional dependencies. So the dependencies, click on the side, blah blah blah, copy and paste the following. So SFML graphics, SFML window, SFML system, or SFML network, and SFML audio. Authenticated place. Okay. So planning Timber. Whenever you make a game, it is always best to start with a pencil and paper. Okay, I don't have a pencil and paper here. If you don't know exactly how your game is going to work on the screen, how can you possibly make it work in code? Okay, yeah, it makes sense. Let's go for some paper here. So, where's that paper? Is this completely full? So at this point, if you haven't already, I suggest you to go and watch the video of Timberman in action, so that you can see what we are aiming for. If you feel your budget can stretch to it, then grab a copy and give it a play. It is often on sale for under $1 on Steam. So let's watch again I'm gonna move this here so you can see it too. Let's watch this together, and this is the game that we are gonna supposedly do. Oh. Okay. I had no idea what was this game about, but it is cool to know it. Okay, that's the thing that we are gonna do. Cool. Okay, let's go back. Time is always running out. You can get it more by chopping the tree. Chopping the tree causes the branch to fall. The player must avoid the falling branches. Okay. And repeat until runs out or the player is squished by a branch. I didn't. Okay. I thought that it was just trying to get as much as we can get, but yeah, he's actually, yes, he is avoiding. They are just avoiding the branches. With the multiplayer, if we are gonna do the multiplayer thing here, it is gonna be awesome. Okay, freaking cool. Yes, super cool. Cool. So we have a player's current score, decorative floating clouds in the background, yes. A chopped log, that is the portion that we are just chopping. The lethal branches, okay. Decorative P, okay, some elements just to decorate. The tree, shrinking time bar, okay, yes. And the player character, okay. So you can see that we have the following features. The player's score, each time the player chops a log, they will get 1 point, okay. They can chop a log with either the left or right arrow. I'm gonna just put this here because this is just kind of uncomfortable to hold. Okay, yeah, now I feel better. Player character. Each time the player chops, they will move to stay in the same side of the tree relative to the cursor key they use. Therefore, the player must be careful which side they choose to chop on. Okay. The player chops a single axe. A graphic will appear with the player character's hand, shrinking the time bar. Okay. I like how they just bullet point the thing that we're gonna do. Gonna just do some pause on my notifications maybe. Okay. So the lethal, okay, shrinking time bar. Each time the player chops, a small amount of time will be added to the ever shrinking time bar. Okay, that's cool. Lethal branches. The faster the player chops, the more time they will win, but also the faster the branches will move down, which each chop. When the player gets squished, and they will get squished quite regularly, a gravestone graphic will appear. Okay. The chop log, when the player chops, a chopped log graphic will whiz off away from the player. Yeah, the portion of the tree that is just moving away. Just for decoration, there are 3 floating clouds that will drift at random heights and speeds. I can implement something like that in the version of the Flappy Bird game that I had stopped working on, but maybe I will resume at some point, maybe soon. As well as the bee that does nothing but fly around. Okay, and the background. All this takes place on a pretty background. Okay, cool. So in a nutshell, the player must frantically chop to gain points and avoid running out of time. As a slightly perverse but fun consequence, the faster they chop, the more likely they squishy the miss. Okay. We know what the game looks like. Yes. How it is played. I'm gonna just and the motivation behind the game mechanics. Okay, sorry, apologize for this. Now we can go ahead and start building it from these steps. Now we need to copy SFML DLL files into the main project. My main project directory is okay, that one. I'm not using DLLs because I'm not in Windows and I just have this. Will I need to use some dynamic libraries a part of just cloning the project? Just cloning and building the library? I don't think. It was created by Visual Studio in previous tutorial. Okay, those are the files generated by Visual Studio, so I should have access to them already because I already built that with CMake. I hope so. So I just have to move the DLLs, which are the window, system, network, graphics, and audio. So okay, now it is time to touch some code. So this is my main function. Feels like this got stopped, so I have to move it again. So okay, now we can just see. Nice. So the code goes here. So in my main, right? My solution explorer, the project assets. So assets are anything you need to make your game. In your case, these assets will include the following: a font for drawing the text on the screen, some audio sound effects for different actions such as chopping, dying, and running out of time, some graphics known as textures for the character, background, branches, and other game objects. Cool. So all the graphics and sound are required for this game are included in the download bundle for this book. They can be found in chapter 1 graphics and chapter 2 sound folders as appropriate. So maybe I need to download that. Where's my Humble bundle thing? So let's go to library. Here on my library, I will look for books. Let's get the zip file. This is the okay, I have already. So let's open Finder to see. So this is the one. So for Timber. So graphics, here I have the font, the textures, and the sound. So we have 3 sounds. So we don't have like a... Okay, cool. I thought we had maybe a song looping on the background. But yeah, never mind. So the question is, where should I place the assets? Because I have a build folder, a lib, and the source file. They have them. this is just by chapters, but not. Okay. I am doing. Should I include the assets folder? So assets should be at the same level. So let's create here assets. I had that dilemma because I don't know if I understood correctly to Cherno that assets folder must be inside the directory. So I don't know if assets should be here or should be here. We'll go to SFML. Because I want to see if we have on GitHub maybe some samples with an appropriated island. So we have the CPP, the CMake list, and the resources. Okay, but resources are in the same as here. So I will just leave it here. And inside here, I will move then the sound. So I will create sounds. I will also create hello. Yeah, I will create a new folder that is textures, and I will create fonts. So here I will start just by moving this into this folder. Then I will go to graphics. Let's move it to textures. Maybe I should have, I don't know, I'm just overthinking. I just want to structure properly the project, because this is gonna be shown in my profile, so I don't want to do just the stupid stuff. Okay, so we have now that. The font that is required has not been supplied. This is because I wanted to avoid any possible ambiguity regarding the license. This will not cause a problem though, as I will show you exactly where and how to choose and download fonts for yourself. Okay. Making your own sound FBX. Sound effects can be downloaded for free from sites such as FreeSounds, but often the license won't allow you to use them if you are selling your game. Another option is to use an open source software called BFXR from bfxr.net, which can help you to then generate a lot of different sound effects that are yours to keep and do it as you like. Okay, cool. Adding the assets to your project. So I already added them. Oh, I don't like that structure. Yeah, he has like in the same folder, he has not an assets folder, but just kind of all splashed in the project. Okay, exploring the assets. So we have an axe, a background, a bee, a branch, a cloud, a log, a player, rip, and tree. The sound files are in WAV format. Okay, these files contain the sound effects that we will play at certain events through the game. They were all generated using VFXR. Okay, I just want to see which are the sounds that we have here. So, okay. Okay, kind of loud, but okay. Okay, understood. Those are the audio files that I'm gonna work with. Let's add some emojis to my chat. Yeah. So understanding the screen and internal coordinates. Okay, this is cool. And this is interesting. Before we move on to the actual C++ coding, let's talk a little bit about coordinates. All the images that we see on our monitors are made from pixels. Pixels are tiny dots of light that combine to make the images we see on the screen. There are many different resolutions of a monitor, but as an example, consider that a typical monitor have 1920 pixels horizontally and 1080 pixels vertically. The pixels are numbered starting from the top to the left. Top to the left, this is 0, 0. As you can see from the following diagram, our the maximum is just on this. So this is the maximum value, this is the minimum value. Cool. As specified at an exact screen location, a specific and exact screen location can therefore be identified by an X and Y coordinate. We create our games by drawing the game objects such as the background, characters, bullets, and text to specific locations on the screen. These locations are identified by coordinates of the pixels. Take a look at the following hypothetical example of how we might draw the approximately central coordinates of the screen in the case of 1920 and 1080 screen. This would be at the 960 and 540 position. That's the exact middle of the screen. So from that position, we draw the sprite. In addition to the screen coordinates, our game objects will each have their own similar coordinate system as well, like a screen coordinate system. Their internal or local coordinates start at 0, that's 0, 0 in the top left corner. In the previous image, we can see that 0, 0 of the character is drawn at the 96, 0 and 54, 0 of the screen. A visual 2D game object, such as a character or perhaps a zombie, is called a sprite. A sprite is typically made from an image file. All the sprites have what is known as an origin. Yeah, the pivot point. If we draw a sprite to a specific location of the screen, this is the origin that will be located at the specific location. The coordinates 0, 0 of the sprite are its origin. The following image demonstrate this. Okay, we have like an image with a 0, 0 coordinate position, and that's the origin of that sprite. I don't know if here we can just change the origin. For instance, in Unity or any other game engine, you can just set your pivot point or the origin of the sprite. Okay, my nose. Sorry, guys. Sorry, not sorry. Illustration of us. Okay, yeah. Therefore, in the image showing the character drawn to the screen, although we drew the image at the central position, it appears off to the right and down, just because the origin. This is important to know as it will help us to understand the coordinate we use to draw all the graphics. So I was having that issue with the other project that I was building with Raylib and C because yes, I could tell that there was like the elements were not positioned where I exactly wanted, and probably it was because of this. Note that in the real world, gamers have a huge variety of screen resolutions, and our games will need to work with as many of them as possible. In the third project, we will see how we can make our games dynamically adapt to almost any resolution. Okay, so until the third project, we are just starting the first one. In this first project, we will need to assume that the screen resolution is 1920 by 1080 or higher. Now we can write our first piece of C++ code and see it in action. So getting started with the coding game, open Visual Studio, open Timber, blah, blah. So, okay, the source file, blah, blah. Yeah, delete the entire contents of the window. So the idea is to have, they say, I want to see first if you are still seeing my, yeah, this is still working. So the idea for them is to just leave this as like this with nothing yet here. So they want me to just have this. Yes, so objective, features, blah, this book. So making your code clear with comments. So I'm not gonna add some comments. This is the main function. So it is what is known as a type in C++. As many C++ has many types. Yeah, I know. Integer is just one of the types here. The main part of the name is the section is the code that follows. The section is code is marked out between the opening curly braces and the next closing curly braces. Okay. So everything in between the curly braces is part of the ranges. So okay, they are just explaining what a main function. I'm just gonna skip it. Return value. So yeah, we are returning 0, but this can be just removed because we are just working with C++23. But okay, I will just, before I forget, I'm gonna just add some assets. So adding assets. Project assets. So we can just send them there. Let's push them. Okay. So running the game. So they say that I just have to hit play. In this case, I might need to do just this. And nothing happens because I have nothing to display. Okay. Maybe I will try to just put this like here, this way. Let's see how big this looks like. So I have this timber, so essentially we are just running this. So you see it got exit. Okay. Yeah. So the next thing that we have to do is opening a window using SFML. Okay, we are gonna we are gonna do what we were struggling to do with yesterday. So first thing I have to include again. This is just to this is for learning purposes that I just deleted, and I will include it again. Include, and my header file is SFML. Yes, dash graphics. Nothing else. So let's render a window. So it says that if I just say render window without typing SFML, but I don't want, okay, this is a redundant library or header. So I will render a window called window, if I understood correctly, and I will have a VM, comma, timber, comma, style. I assume this is the SF style full screen. It wasn't found. Why? So this VM, I assume this is SF VM. Because this is video mode. I remember, yeah. So because okay, we are just using an old. So this is my video mode, Timber, and the style must be full screen. But feels like this doesn't exist anymore. So let's see what can we find here. Close, default, resize, tile bar. Let's add this one. I don't want to use this, like I don't think this is necessary, dude. So this should create introduction. We have a debugger on set. Ooh, okay. But I'm not gonna use it yet, I think. I didn't know that set has a debugger. Okay, let's go debug. So can this run this? No. Okay, that's cool, but I want to see my terminal. Yes, so let's run this. The thing is, I'm not seeing the window. So yes. Now we will go through. Okay, yes. Okay, the next line is using namespace. Okay. Because this is not. So the idea is to create something like 1920, 18, okay, 1080. This is the resolution we want to work with for this project. Still, I'm not able to see the window, but it is because it is just getting closed automatically. So before that, because I want to fix that, let's go real quick to SFML. And let's go to the documentation, because I do want to see that. So for real, I want to see just a black window screen. So I have to add, I know, the while loop. So it's like while, and inside this while I have to say something like while window is open, or is closed. While this is open, do this. It is something like that. Okay. While this is open, so we have like two different while loops. So while this is open, let's say, because where is the draw? Window that display. Okay, I have to somehow cast when I am closing that. So while, on this case, const std optional. On this case, this is gonna be event, sf event, yes. Event. Then this is gonna be equals to window dot pull event. So this is when I'm closing the window. So close window, then exit. So here is where I will say if event if event is this is the type is if event closed, if the event that it listens is closed, then just window dot close. Let's try to see if this is working. So let's build this. But again, I don't see anything here. So I have no idea if this is still working, because I don't see that. Let's say, for instance, when this is open, let's try to say cout or just print std print the window just opened. Yeah. So let's try to build. I just want to see if this is getting printed somehow. No. So feels like I have to rebuild the whole thing. So let's go to cd build and then cmake that. And then I have to go cd and then just have I built? I think I didn't build that. So let's see, what was the thing that I did? cmake build this thing. It was not able to. So I think I have to go again to cd build and then just try to do it again. So let's build the whole thing again, just to see if I see some changes. And then I go to cd and then I just say, I just build the whole thing again. That was why. Okay, so hey, finally we are seeing. I just want to see how much time it took me to just display the 43 minutes it took me to just display the black window. And I cannot I cannot shut this down. How could I close this window without the option of closing the window? Okay. I don't need the terminal here. Okay. Okay, I'm still printing this. Stop. Okay, I just killed the process. Okay, this is printing here. Wow, look at this. Okay, we are doing like this is opening the window, which is great. Now this is not letting me to close the window. Kind of sad. You are not able to see what I'm doing. OBS is so annoying. So let's see. Let's go to display capture. Let's switch from here to here. And now you can see. So the thing is, whenever I run this, you can see all the logs that I have here. So I had to kill the process because I didn't know that it was running, but essentially I am just having this black window here. You know what? I'm just gonna check every 15 minutes. But I have no way to close it. So I just went to set. I just killed the process because the close option feels like it is not available yet here, which is strange. So let's see what I'm missing here. So okay, yeah, this is the main loop window that close. Okay, I did not clear the window, so window that clear. Yeah, I have to clear the window before displaying anything else. Okay, we are kind of here doing something, so let's back to the book. So yes, we're gonna start with OOP classes. What's going on? Battery is running low here. Feels like I'm gonna need to do something on VR and I don't want to do it. Okay, let's see. Okay. Anyways, let's go back here. So OOP classes and objects. We will fully discuss OOP classes and objects as we proceed through this book. What follows is a brief introduction so that we can understand what is happening so far. We already know that OOP stands for Object-Oriented Programming. OOP is a programming paradigm that is a way of coding. OOP is generally accepted through the world of programming in most languages as the best, if not the only. Professional, it is not the only because there is ECS and other ways. There is like functional programming and stuff like that. So, okay, okay, OOP introduces a lot of coding concepts, but fundamental to them all are classes and objects. When we write code, whenever possible, we want to write code as is reusable, maintainable, and secure. I'm gonna do a brief pause here because I have to find a project I worked on like few years ago. Concéntrese was the name. Concéntrese. Okay, yeah. Stop right here. Concentre. Sí. I don't know if I have still that project here. Thyroid impulse, Zelda like, Tone tanks, barrel tanks, apple catcher, battle cost, time control module, hospital, grip rider, resources, landmarks. Stand drive simulator. Ferry Babylon JS. I don't have that concentracy. I don't have them. It means, let's see if I can sort this by. It usually says snake, control module, grip rider. I'm like, let's see, what about C#? UI toolkit, input barrel tank, multiplayer netcode, Vision OS, Palm launcher. I was doing okay, have to clone real quick a project here just to check and temp. I just get rid of this just for a second because I don't know. A terminal add folder, so let's clone the whole thing. Let's see if I can clone this thing. It was not found, so let's go with the HTTP thing. Okay. No, this is not what? No, this is not what I'm looking for. I just copy a description and not the link. Nice job, David. Nice job. Let's see. Copy this here. Okay, let's open this one real quick in Unity just to see if this is the game that I was looking for. I'm just gonna use the latest one. Yes, change the version. I had like a lot of projects that were developed 5 years ago or something like that, and now people is asking me for those projects. Let's see if this is still Estoy buscando, espera que lo estoy buscando. What? Okay, spamming bots on Twitch are slower than on Kick. There are a lot of the okay, I'm just gonna remove this one. Yes. Let's see, where are the scenes? I put this here so you can see what I'm doing meanwhile. I just switch real quick to Unity to see if I have an working project. No. Oh, I did. Don't remember this one, but that's cool. So I had this. Is this still working? But it does nothing else. Like I have the... okay. No, this is doing nothing. Okay. Okay, I'm gonna tell her that I don't have the project. Okay, never mind. Let's back here. So we were talking about some oops. So for example, if we wanted 100 zombie NPCs, non-player characters, we could carefully design a code and code a class called zombie, and then from that single class create as many zombie objects as we like. Each and every zombie object would have the same functionality and internal data types, but each and every zombie object would be a separate and distinct entity. Yes. To take the hypothetical zombie example further, but without showing any code for the zombie class, we might create a new object based on zombie. This zombie Z1. The Z1 object is now a fully coded and functioning zombie object. We could then do this zombie 2, zombie Z2, zombie Z3, zombie Z4, zombie Z5. Now we have 5 separate zombie instances, but they are all based on one carefully coded class. Let's take things one step further before we get back to the code we have just written. Our zombies can obtain both behaviors defined by functions as well as data which might represent things such as the zombie's health, speed, location, and direction or travel. And as an example, we could code our zombie class to enable us to use zombie objects perhaps like this: Z1 that attack player, Z2 growl, Z3 head explode. Note again that all this zombie code is hypothetical for the moment. I don't type this code in Visual Studio. Okay. So let's say we need to assign a unique name and speed in meters per second at the time we create each zombie. Carefully coding of the zombie class, we could enable us to write this. So Dave has a 100-meter Olympic champion before infection. He goes, okay, let's see. So another 15 minutes. I will see just if this is still working. Yes, this is still working. He moves at 10 meters per second, zombie C1, Dave. Okay. Jill has both of her legs eaten before she was infected. She drags along at 0.01 meters per second, like 1 centimeter per second. Zombie C2, Jill, 0.01. The point is that classes are almost infinitely flexible, and once we have coded the class, we can go about using them by creating an object instance of them. It is through classes that the objects that we create from them that we will harness the power of SFML. And yes, we will also write our own classes, including a zombie class. Okay, then they do the using namespace SF. Okay. Okay, using namespace SF. Yes, here they will start explaining essentially why we should have like using namespace SF. But I don't know, like I am not proficient C++ developer, so I think this practical, but it is not a good habit because we might need, like, this will let me to skip writing this. But for instance, for the event, I think there is an event in another library. So SF lets me know that it is part of SFML. So yeah. So SFML window video mode and render window. Inside the main function, we now have 2 new comments and 2 new lines of execution in the code. The first line executable code is this video VM. Okay, so they created an instance video mode. So let's see, SF video mode VM with this thing, I think 20,80. So this is VM. No, because this is the constructor. Okay, hold on. So I have to say that inside here I will have this one and this one. And with this, so I don't need to type this here, but I just can have a VM, comma, that is this. It is, I don't know, like I come from C# and I think that this is like no issue, and this helps a lot for reading. but I don't know, we are just creating a new instance of something that is gonna live here and it's gonna be used only here, so I don't know. Then they talk about render window, which create the instance window, passing VM, Timber, and the style that is not full screen. So full screen seems like it is not available yet. Not available now in this SFML 3.0.1 version. But yeah, anyways. In the previous line of code, we are creating a new object called window from SFML provided class called render window. Furthermore, we are setting up some values inside our window object. Okay. Firstly, the VM object is used to initialize part of the window at first. This might seem confusing. Remember, however, that a class can be as varied and flexible as its creator wants to make it. And yes, some classes can contain instances of other classes. Yes, of course. Yes. Okay. It is not necessary to fully understand how it works, blah, blah, blah. Okay. Next, we use the Timber. So they are talking about this one. Timber, I will just put this here because this is just the name. So we use the Timber value to give the window a name. Then we use the predefined style full screen value to make our window object full screen. So again, full screen is not part of this anymore. Apparently, we have just the default non-resized and tile bar. So yes, I have just resized this, but no, I don't want this, and I don't need this either. So yes, not needed. Okay, running the gaming. Actually, if I select close, hold on, I just want to. If I say, but I have to generate a new instance. So because I have to do like. I have to go here and then I have to just build the whole thing. What? No. CD Timber. Okay, inside Timber I have to go CD build, then CD make dash dot, and then I have to wait, and then I have to just CD make dash build, so it builds the whole thing, and then I have to go back, and then I have to say I don't need to go back, do I? So I can just say Timber. Okay, Timber. So I have to go back, and then I have to say build Timber. What was the thing that I was doing? And then I can open. Okay, now I have the option to close this. Okay, so if I just leave this style as default, it should show me the three options, right? I assume that. But I have to do this again and again and again, so I will just create a bash here. So let's go to Copilot. Help me to create a bash file to build and run my project. So let's create here. This is gonna be build and run. This takes just build and run. Build run .sh. So set E. This is just the exit error. I'm gonna do this. I'm gonna do this bash file because I don't want to just move back and forward just to build the whole thing every single time. So let's build directory, which is built, but it is already built, but just in case. Then I create a directory that is just build directory. Yes, thank you. Now let's go to cmake s-b build directory. Yes, and then dcmake build type equals debug. Yeah, for now debug is okay. And then cmake -- build all my build directory. So build directory. I think I missed this. So build directory. Let's go to the end. Parallel. Okay. And then just execute the whole thing. That is essentially build directory / timber. So let's try to say chmod +x build run .sh, and then every time I want to run it, I just do build run .sh. Oh, bro, I'm getting some. Okay, it runs. Cool. I think this is for the. So if I run this again, will this create a new? Clean. No, this is gonna be quicker. Okay, yes. Now I have just to okay. Let's add this. Mac window. Okay, before Mac Linux bash to build and run the project. So I don't have to type the whole thing in the terminal every single time. So could you create a bash file for Windows, please? Like on Windows it is a PowerShell, right? What? Okay. Time to see if you are able to. Not yet. Now you are not able to see what I'm doing. So properties, switch the screen. Now you can see what I'm doing. Okay, cool. Let's reload this. And generator Ninja is fast across platform. If you are using Visual Studio, swap it, or whatever version you are using. How could I run that? Okay. So git bash, okay. So inside the bash, could we create a conditional or something to ask if I am in Windows, then use the Ninja thing and the exe file, or otherwise use the original sh file. Okay, this is so I just found that it is possible to have like a single bash file, and inside that bash file I can detect if I'm on Windows, then I can execute something, or if I'm not, I just can execute the other thing, but it is kind of blowing up. So I set there, so I have my build directory and I have my executable, that is Timber. So I define those, then I have to say uname out equals to, then I have to say, bro, this is like black magic. So I have here just uname space s. So this theoretically is to store or to get the operating system that I have. Hold on, please give me a second. Give me a second, please. So with this, I theoretically should be able to detect like what is the operating system I am on. Then I have a case, like a switch statement. So case, on this case, uname out. Wow, in. This is like black magic to me. So with this, I should be able to define I am on Linux, I am Darwin. So if I'm Linux or Darwin, I have no idea what is Darwin about actually, but it is interesting. Wow, this is so weird. If I'm in one of those, then platform equals Unix. Okay. Then generator is equals to something. Executable equals something, and then semicolon. Oh, hold on. And then semicolon. I don't understand the syntax at all, but okay. Then if this is mean, I assume this is Windows, or okay, hold on, I have this wrong. I have this, or I have MCs, or I have Cwin, and then I have the same platforms. I'm gonna just copy this and I place this right here. So move them here. Okay, and I think this is the default case, that is asterisk. This is for the default case, I think, yes. So if not, if you cannot detect that, echo unsupported platform, and then I print out the name of the detected platform, that is uname out. Interesting, this is the first time doing this. Then it says exit 1 and then semicolon. And then I think Isaac is to conclude the switch statement. Then I have a couple of messages that I don't know why were they generated, like if they are actually relevant. But for debugging, I don't know. Echo, let's just put them there. Okay. But before that, I have to fill these elements out, right? So this is Unix. The generator here is Unix make files, and the executable is here at build directory / and then executable. Oh, I wrote this, but okay, executable. Executable. So yeah, This is the name of the variable that I have. Yes, yes, yes. Okay, cool. This is gonna be the executable without any extensions. And if I'm here, this is Windows. And then I will use Ninja, that it says it comes when installing CMake or Git Bash. So hopefully it works. Ninja, and here this is gonna be the same as here, like the build directory, but the only difference is that we are gonna have executable.exe. So I have this like the detected platform is the platform that I just detected. So platform, yeah. I will close this one here. Voy, dame un segundo, porfa. Then I will say echo using generator. So I will just print out the generator that I have. A generator. Okay. I want to see if I have without capital. Okay, no. Yeah, cool. It works. And then I have I create the directory build that is here. So I create this. Then I use CMake. Same with build directory. For some reason I have to add this G, and then on quotes I have to place the generator. Then I have this dmake file, yeah, dcmake build file, build type, and it is debug. Okay, I'm gonna just leave it as it is. And then I build the CMake in parallel, and then I just print echo running, and then I just place the executable here, executable. So with this, in theory, this okay, this instead of this I should just run executable, right? Executable. Here instead of these braces I should just remove them. I'm just calling directly here. Okay, this executable. Okay, just okay. So with this we should be able to, here is without braces, here without braces. I'm just calling the okay, let's see if this thing works. So in theory with this we should be able to build this on Mac and also on Windows. So creating, let's go here. So creating a bash, creating a bash for Windows and Unix like systems. Just gonna update this. Actually, I should also modify the README file before. This is my README. Good, pues let's see. Let's go real quick to my repositories. Timber. Yeah, sorry guys, I'm not programming in C++. I stopped, but I had to just do it the bash file because it was driving me crazy just having that, like doing every single time the whole thing. So let's update real quick my readme. So let's have these prerequisites. So let's go right to the end and then make sure that I have everything here. So okay, it's time to check if you are still seeing what I see. Yes, you do. So let's put this another 15 minutes. So optional is like CMake. This is this one, this one, this one, this one, this one. And this one. So this is the prerequisites. I will have then clone the repository. So I just copy this. How could I do this? I think it is with 3 here and 3 here, just to put some code. Then I have to add the build and run thing. So build and run. So this is with a cross platform bash script. Okay, yeah. Oh, David. So it has to be replaced here. So with this, I will just do the same thing, right? 1, 2, 3. I just copy this. And 1, 2, 3. And after that, yeah, I don't have any alternative for that. Okay, I think with this, that should be enough. Let's see what I'm missing from CMake. So dmake, export, compile. Yes, I have that one for release builds. Yes, I think with this, I have the update. Thank you. Okay, just we'll leave it as it is. I will just update this installation and build instructions. So let's publish this and let's see how this looks like on the GitHub page. So I have this, so make sure you have installed the following: the compiler, plus the for IDE integration. So I have that one. It is generated. So I think the last part is Git is not Git is optional. No, Git is not optional at all. I don't know. I should remove one line, like my CMake file is. So could I remove the optional part Okay, yes, I'm just gonna remove the optional thing because it doesn't make sense to keep it here. It is already getting generated, so yes. And let's just fetch my content. So let's pull what I have. That is essentially the update for my README file. And here I'm just creating a window with close, resize, and minimize options. So commit this and let's push this to origin. Okay, let's check this back. So you are still being able to watch this. Okay, I have now my README file ready. So just it's kind of nice. And now let's go back to the programming side. So what I will do is I'm gonna do a quick pause. So I'm just gonna grab some coffee and stuff like that. So please give me a second. So I'm just quick pause while grabbing a snack. I'll be back. So just wait for me. Give me 15 minutes, please. What is my SoundCloud? SoundCloud is here. Yeah.
No encontré la fórmula de, pero le ordené la historia a su abuelo para el viernes. Me toca madrugar ese día, David, porque toca por tardar a las 7, porque tengo que facturar.
back. I'm back, guys. Sorry, I was just grabbing some snacks. So let's get rid of these comments. What is happening with the music? I cannot hear anything. Where is the music? Hello? Why I'm not able to play this? Hello? Let's see. YouTube, let's put a random video meanwhile. And I think you are not able to see what I see. Yes, it is frozen the screen, so let's go to properties. Let's switch the screen. So now you are able to see again in real time what I'm doing. So let's put some.
Here's how I saved my game from burning to the ground right after release.
Okay, cool. So sound is working here, but not sure in SoundCloud what's going on. Let's go to the next one. What is the one that I'm currently playing? So I will just reload the whole thing because I need some music on the background. So I was like, let's play from Euphoria. Hello. I don't know. This feels like it is not working. Okay. Now we are vibing. Okay, let's get back to what we are doing. So, okay, now we are back on C++. Now that we have our bash file, so everything is a lot easier. And I'm kind of happy with this. So the repo looks like this. So it has Timber clone in C++ and SFML. So it has the prerequisites. So I just have listed all the stuff that I need. Then we clone this and we build and run this bash and then add thank you. So for now it is enough, it is cool. And the idea is to just speed up the development process here a little bit, just to get some juicy and spicy gift files in order to show some gameplay on the README file. So okay, what we were doing, okay, we are gonna talk about the game loop. These are some things that we need. Okay, hold on, excuse me, because I have to do something quick right now. Summarize. Oh, hold on. Give me a nice summary of this with less than 2 lines. Let's create a new one just to see how many lines this takes. Yeah, could you? So first one. Let's go to the other one. Okay. Where are the ones about Andre? Where is Andre? Andre. Because if I see this one here, Andre sent me that, and I don't know where he did it. I think it was on messages. Let's see, Andre, where are you, Andre? Andre, Nikolai. Okay. No. How could I? Don't give me a second. I'm just running with a summary of someone who gave me this one. So okay. So the full name of this is okay. Okay, back to what we were doing. Sorry guys, but I don't have a job, so if I see a message on LinkedIn, it is a priority for me. So let's see real quick, what do I have here? Okay, cool. I think we are good for now. So what's the next step? What we are gonna do or achieve? So many structures, dude. People will be happier if they don't use any how could I say, any mobile device. Okay, so the game loop. There are some things that we need our program to do that we will achieve in this section. We need a way to stay in the program until the player wants to quit. At the same time, we should clearly mark out where the different parts of our code will go as we progress with Timber. Furthermore, if we are going to stop our game from exiting, we had better provide a way for the player to exit when they are ready. Otherwise, the game will go on forever. Okay, that's true. That's what we were getting with these logs, like the window just opened. Actually, I'm gonna just get rid of this. I should, in fact, get rid of all these debug messages. But okay, it is removed. Add the following highlighted go to the existing code, and we will go through it and discuss it all. So what is the thing that we are gonna do? So inside this while loop, so this in theory, like this while is essentially the main loop. So while this is open, we will handle, we're gonna do some stuff. So handle the player's input is the first thing. Then we are gonna update the scene. Then we are gonna draw the scene, draw scene. Yeah, the scene. And finally, we are gonna do the stuff like clearing out the window, draw the game scene, and why are we having like a draw the scene and then we are gonna draw the game scene, and we are gonna show everything. So with this, okay, so we have that. So let's begin here with the input section. So let's begin with if, so keyboard, so as if keyboard, then is key pressed. This reminds me the old input system, Unity's input system. Keyboard escape. Okay. Localize depending on the layout set. Operating system can be mapped C or C. Okay. So I would say key escape. Escape. Okay. So we are gonna see if escape is pressed. If it is pressed, I think yeah, we are gonna close the game. So window dot close. Yeah, this is the case when we just pressed escape. Then we are going to update the scene that is not implemented yet. Then we are going to draw a scene, and then we are going to do the other stuff. Okay, cool. This is kind of the code that we have until now. So if I let's clear. Okay, so if I run again, build run rush. So we have this open, yes, yes, Z, yes, quit and reopen. Okay, okay, again. So let's run the bash file again. Oh, in my repo the bash file is called okay, if I press escape, hey, now we know how to cast some key things, right? Let's go here real quick because I think this is called build run. You know what? Build and run. Just leave it as it is and just try to rename this as build and run. Yeah, build and run. Okay, so let's say build and run. So it generates everything, so cool. And I press escape and it works. Okay, cool, nice. So I will just say this cache from CLang should be ignored, right? So okay, first of all, bash main bash file renamed for consistency. So let's push this out. Now this one, I think this should be like, let's see if I can just ignore this file. So idx clang file. Which are those? The index checks for a cached disk. After indexing, it writes this file. It avoids to reindexing on startup. So the question is, this, like, should this be ignored or not? Should this be added to git ignore? I just want to know if that's an important file. So that cache index file should be definitely be added to your git ignore. Okay, so okay, so let's open up real quick my git ignore here, and I will add any cache file. So I should add this one here. Okay, hold on. Cache. So everything inside this and everything inside C lang D. So let me add some more files here from the IDEs like Beam and stuff like that. And let me add in build. We'll add just like any other variant of build, but I'm gonna stick to build. So this is just a quick update for my git ignore. So updating git ignore. Okay, so let's commit this file, push it. So yes, this one can be just ignore this. This is already added, like, yeah, it appears here. So ignoring cache from C lang. But if I will add them, okay, because they should be just deleted. Okay, so back again to C++. So which are the while loops? The while loops, we have in while loops this one, that is while window is open, then we're gonna do everything. So every last thing we saw in the new code is a closing brace. We have created a while loop. Everything between the opening and closing brackets of the while loop will continue to execute over and over, potentially forever. So that's why we added is open. So I'm gonna just skip this part because it is kind of obvious for me. The next statement is of course return 0, which ends our game. We now know that our while loop will whiz round and round, repeatedly executing the code within it until our window object is set to be closed. So C style code comments. So okay, yeah, I'm gonna just ignore them. So let's talk about the input, update, draw, and repeat. So for that, although this first project uses the simplest possible version of a game loop, every game will need these phases in the code. Let's go over the steps. So get players input, if any, update the scene based on things such as artificial intelligence, physics, or players input, draw the current scene, repeat these steps at a fast enough rate to create an interactive, smooth animated game world. Yeah, so input, update, draw, and repeat. Okay, cool. Now let's look at the code that does something within the game loop. So detecting a key press. So we are on this section. So okay, gonna have a look on that. So firstly, within the section that is identifiable by the comment with the handle player's input text, we have the following code. If keyboard is pressed, keyboard escape. So in this case, because we are using newest or more recent version of SFML, we have if keyboard is pressed, yeah, that's still a thing. Then inside the parameter that we add is keyboard, then key, then escape. And if the condition met, just we close the window. then clearing and drawing the scene. So currently there is no code in the update the scene section. So let's move to the draw the scene section. The first thing we will do is wrap out the previous frame of the animation using the following code: window.clear. So this one, essentially, before we display anything, we are gonna just clean what we have there before displaying that. And then the next line is window.display, that is to present in the window what we are just about to display or render. So okay, let's check real quick that we are still seeing this screen, so we are not seeing it. So let's switch here and let's switch here, so now we can see. The next section, so running the game. Run the game and you will get a blank full screen window that remains open until you press escape key. Yes, that's what we saw. So if I run this, it's gonna load, and if I press escape, it gets closed. So drawing the game's background. Now we will get to see some graphics in our game. What we need to do is to create a sprite. The first one we will create will be the game background. Okay, cool. We can then draw it in between clearing the window and displaying, flipping it. So preparing the sprite using a texture. So the SFML render window class allowed us to create our window object. So we are here. Our window object. Which took care of all the functionality that is in our game's window needs. We will now look at two more SFML classes that will take care of drawing sprites to the screen. One of these classes, perhaps unsurprisingly, is called sprite. The other class is called texture. A texture is a graphic stored in video memory on the graphics processing unit. An object that's made from the sprite class needs an object made from the texture class to display itself as an image. Add the following highlighted code and try and work out what is going on as well. Then we will go through it a line at a time. So essentially I have the render window. Then I will create a texture to hold a graphic on the GPU texture background. Load that graphic into the texture background. So all these steps need to happen before getting into the main loop. So yes, create a texture to hold a graphic on the GPU texture texture background. We have load that graphic into texture background, load from file. So I will look for I don't have graphics, but assets and then textures. Create a sprite background. Attach the texture to the sprite background, set texture, and then I pass the parameter of the texture, and then set the sprite background over the screen. So let's try. Okay, so what you are telling me to do is I need to create first a texture. I said texture. That is texture background. Okay. Then I have to set the stuff in this texture. So the next step is to say texture. So texture background dot load from file, and then here I will just put this in quotes, and on this case I might need to use assets / clang, no, slash textures, I think. Textures slash, and then the image that I want to load, that in this case is background.png. Background.png. So this should load the texture on the texture background object, and then we have to create the sprite. So sprite on this, sprite background, but this sprite is SF sprite. So I'm just creating this new object. Why I'm not able to create this object in this way? And then I have to assign sprite background that set texture, and in this case I will send my texture background. Okay, this is the thing that I'm gonna send. Now, why am I getting this error? Not matching the constructor initialization. So it should be equals to this thing. So I will check real quick the documentation. In the documentation they have like how to load a sprite. Okay, so when I'm creating this, so on this version apparently I have to set immediately the texture background as a parameter, because that's what it is getting asked in the constructor. Okay, cool. I should also, for these cases, I should go to definition and check what go to declaration. So it has an explicit texture. So I have to pass always the reference of the texture that I'm gonna add. So it cannot be left without anything. So okay, nice. So I have the texture, the sprite texture called sprite background, and then I have to set the position. So I think it is gonna be at position 000. So set so sprite background, yes, and that's set position, and here I will say this is gonna be at 0,0 because I'm just getting a vector 2. So the texture with the pivot or to the origin in the top left corner is gonna be placed at the position 0 of my screen. That is also the left top most position. So yeah, I have the sprite loaded, so this is essentially what we just have done. So I will get rid of these comments. And what else? Okay, I have the background, and then I have to display it. So I set the position. Okay, so since the background.png graphic in the graphics folder or assets is 1920 pixels wide and 1080 pixels height, it will neatly fill the entire screen. Just note that this previous line of code doesn't show the sprite. It just sets its position ready for when it is shown. The background sprite object can now be used to display the background graphic. Of course, you are almost certainly wondering why we had to do things such as convoluted in such a convoluted way. The reason is because the way that graphics cards and OpenGL work. Textures take up graphics memory, and this memory is a finite resource. Furthermore, the process of loading a graphic into the GPU's memory is very low. Not so slow that you can watch it happen or what you will see in your PC noticeably slow down while it is happening, but slow enough that you can't do it every frame in the game loop. Okay, so it is useful to disassociate the texture background from any code that we will manipulate during the game loop. Okay, cool. As you will see, when we start to move our graphics, we will do so using the sprite. Any objects that are made of the text from the texture class will still happily on the GPU, just waiting for the associated sprite object to tell it where to show itself. In later projects, we will also reuse the same texture object in multiple different sprite objects. Okay, yeah. Which makes efficient use of GPU memory. In summary, we can state the following. Textures are very slow to load onto the GPU. Textures are very fast to access once you are in the GPU. We associate a sprite object with a texture. We manipulate the position and orientation of the sprite objects, usually in the update the scene section. We draw the sprite object, which in turn displays the texture object that is associated with. So all we need to do is to use our double buffering system, which is provided by our window object to draw the new sprite object, sprite background, and we should get to see our first graphics in action. Okay. So. So in theory, we have to now that we have created our sprite in memory, all we need to do is just to this section, this code. We need only to draw this. So while having this, so let's I'm gonna put it here. Yeah, I'm gonna leave it just here because this is the section where we are just waiting to the close event. Actually, we can't get rid of this because we are using just escape, but I'm gonna leave it because we are at some point write it. So yes, I wait for the closed window. I handle the input, and here in update the scene, we are not updating it, but we are gonna draw. So window dot draw. I will draw on my sprite background. This is the thing that I want to draw. But it has to be okay. I don't know if clear should be before drawing anything. Yeah, in fact, indeed, clear needs to happen before. Before the drawing. So with this, I think we are just ready to see the background image. There we go. We now have our background image on the window. So I'm gonna press escape. Finally, we are able to unused result. What is this? Okay, this warning is telling me that I'm not using the texture background, but I'm using it. Yes, so they are telling me that this ignoring return value function declared with non-discard attribute. I don't understand still this, but I'm gonna just ignore it. Or just let's check real quick. Because this has to be constant, right? It's because of that. Const. Because now I can just download, I can just load my texture background. So I can just do this. And this should be enough, so I don't have any warning. Let's run this again. Okay, so I don't have to do that double step, I just can declare it directly here and I'm not gonna get any warning. Okay, cool. So drawing. But the headers, for some reason, Z tends to create all this. Yeah, Z tends to create all those redundant headers, so this should work normally. Okay. Okay, so this is a lesson learned, so cool, kind of happy with the result. And so it is updated, so let's see, loading, background. So loading a texture and placing it in as bright as background. Okay, kind of happy with this. Okay, hello Ronald Carlos. Hello Ronald, welcome. Okay. Meanwhile, I'm gonna continue with okay, I need to see. Are you still watching this? Okay, cool. How much? I'm gonna 15 minutes more. So okay, that's how we draw a sprite on background. So the running game, yes, he's not going to get a game of the year in its current state, but we are on the way at least. Okay, cool. Let's look at some of the things that might go wrong in this chapter as we proceed through this book. So handling errors. There will always be problems and errors in every project you make. Yes, that's true. This is guaranteed. The thugger the problem, the more satisfying it is when you solve it. Oh, yes, this is like dopamine driven development. When after hours of struggling, a game feature finally bursts into life, it can cause a genuine high. Without this struggle, it would somehow be less worthwhile. At some point in this book, we will probably be some struggle, so remain calm, be confident that you will overcome it, and then get to work. Remember that whatever your problem, it is very likely you are not the first person in the world that have had this same problem. Okay, it is potentially true. I just had to face once a challenge that was very unique at that time with accessibility features and a very old version of Unity, but yeah. Think of a concise sentence that describes your problem or error and then type into Google or ChatGPT. You will be surprised at the speed and precision of solving a problem this way, as often someone else will have already solved your problem for you. Having said that, here are a few pointers to get you started in case you are struggling with making this first chapter work. So, configuration errors. The most likely cause of problems in this chapter will be configuration errors. As you probably noticed, during the process of setting up Visual Studio, SFML, and the project itself, there are an awful lot of file names, folders, and settings that need to be just right. Just one wrong setting could cause one of several errors whose text doesn't make it clear exactly what is wrong. And it reminds me what we were living yesterday, because I didn't know how to set up properly the SFML file with CMake and with this new version of C++. Thanks for asking. Okay. How about you? Okay, back here. So, compiler errors. Compiler errors are probably the most common errors we will experience going forward. Check that your code is identical to mine, especially semicolons, on the ends of the lines and subtle changes in upper and lower for class and object names. If all else fails, open the code files in the download bundle and copy and paste it in. I try to avoid copying and pasting just because I need to do the exercise at least, so my brain can retain some of the stuff that I'm doing. Link errors. Link errors are most likely caused by missing SFML DLL files, so we are not using DLLs here. We are just using the CMake build, so it should be good. So, okay, bugs. Bugs are what happen when your code works but not as you are expecting it. Debugging can actually be fun. The more bugs you squash, the better your game and the more satisfying your day's work will be. The trick to solving bugs is to find them early. To do this, I recommend running and playing your game every time you implement something new. The sooner you find the bug, the more likely the code causing it will be fresh in your mind. In this book, we will run the code to see the results at every possible stage. And in summary, this was a quite challenging chapter. It is true that configuring an IDE and a use C++ library can be a bit awkward and long. Also, the concepts of classes and objects are well known to be slightly awkward for people who are new to coding. Now that we are at this stage, however, we can focus on C++, SFML, and games. As we progress in this book, we will learn more and more C++, as well as implement increasingly interesting game features. As we do so, we will take a further look at things such as functions, classes, and objects to help demystify them a little bit more. We achieved plenty in this chapter, including outlining a basic C++ programming with the main function and constructing a simple game loop that listens for player input and draw a sprite, along with its associated texture on the screen. In the next chapter, we will learn about all the C++ we need to draw some more sprites and animate them as well. So we have some frequently asked questions, and then we are gonna jump into the game development, I think. Okay, so we have variables, operators, and decisions animating sprites. So learning about all C++. So the idea is to learn all the C++ variables, seeing how manipulate the variables, adding clouds, buzzing B and a tree for the player to chop away at random numbers. You know what? I want to download this. Do I have this open here? So I want to see the audio program he mentioned that is for free. So let's find sound. Free sound over here. Hello. Because before jumping there, here the book recommends me to use this page that I will save for sure, because we can just we can generate. Oh, this is actually a really cool program. We can just create the sounds that we want. Here, I'm gonna save this. How could I save this in Safari? Bookmarks. Show add to bookmark. Yes. Sound generator VFXR. Okay, now I can close it in peace. Yes, we can add these brackets. Okay, so back here, so learning about C++ variables. I'm gonna, okay, we have some types of variables: int, float, double, char, bool, string. I know already that. String? Any text? Okay, but we have to import from the standard library the string thing. That is just an array of characters. So let's create then some variables here. So we might need to create but should be there. Okay, the stages are declaration and initialization. Let's look at each turn. Declaring variables. We can declare variables in C++ like this: int player score, char player initial, float value p, and bool is alive. But I don't know if they should be global. I don't like them to be global. But okay, let's leave it. Let's leave them here. So let's create integer player score. That is gonna be 0. Then I will create a car player initial. That is gonna be just it's gonna be empty. Okay. Then I will have this float value p. That is just 0 for now. And then we will have this bool is alive. That is gonna be true. So they are initialized. So let's say 3.141f. Okay, I have these variables. So this one can be j. So okay, we have then the variable, then we have the constant. So sometimes we need to make sure that a value can never be changed. To achieve this, we can declare and initialize a constant using the const keyword. The value of p doesn't change, so it would be more correct if, in most cases, to have used as a constant variable. So let's rename this, or let's say this is just a constant float. But in this case, this should be, instead of value of p, this should be p, because constants usually are in capital. So in the preceding code, we guarantee that the value of p variable can never change during the program execution, and either can the number of enemies. Okay, because I had a number of enemies. When declaring constants, it is common to use a different format. The format we will use in this book, it will be all uppercase with the words denoted by underscores instead of camel casing. To be clear, when I say that constant can never be changed, it means it can't be changed by the program execution. As a programmer, you can always change the value of your constants at initialization time. You just can't write code to change them during execution. So the uniform initialization or list initialization is a newer way to initialize variables. Uniform initialization is in C++ began with the introduction of C++11, which has a major update in the C++ programming language in 2011. Uniform initialization provides a more consistent syntax for initializing variables, and our user defines types. It allows initialization using curly braces, just like the curly braces that wrap the main function. You can use uniform initialization for the variables we saw previously as follows. So essentially, this is the way how people initialize variables in C++. It was strange for me, but yeah, because the first time I learned C++ it was in 2010 and it was with the equals, and since then I've been using C# and Java and other languages. So yeah, it was kind of an interesting jump. Okay, so create an object of type video mode called VM and initialize it with 2 values. Yeah, we already have done that, seeing how to manipulate variables. So let's see real quick if you are seeing what I see on the screen. No, you will see what I have on my screen. So let's check this by another 15 minutes. So yes, initialization of variables, and this is what I have on the code. So we have on C++ arithmetic and assignment operators, so plus, minus, the asterisk, the slash, and the module. So we have assignment operators that are equal, plus equal, minus equal, asterisk equal, dash, slash equal, plus plus, minus minus, and greater, less, or equals operators. So getting things done with expressions. Expressions are the combination of variables, operators, and values, just like expressions in English are the combination of words and punctuation. Using expressions, we can arrive at a result. Furthermore, as we will soon see, we can use an expression in a test. These tests can be used to decide what our code should do next. So first, some simple expression we might see our game score is high score equals score, or score equals 10, 100. So let's see another example. Score equals aliens shot plus waves cleared, and so on. So we do some math here. We update some with plus plus, with less. So let's look at few more operations in addition, and then we can go back to the build the time per game. So it tries to say, so some variable equals 10, some variable times equals 10 is the variable with the value of some variable times 10, and so on. Yeah. So let's begin by adding some clouds, the buzzing bee and the tree. So let's start by preparing the tree. So we have until now the video mode, the render mode. Then we have to create the texture. We have the texture background. Okay, so what we have to do now before the while loop is to create then we have to create the texture tree. So it is also another constant. So const sf texture tree. In this case, this is allocated in assets, textures, and tree.png. Then sf sprite, we define the sprite, this is tree sprite. Sprite tree that contains on it texture tree. Okay. So let's create some constant values here, but I don't know where should be they allocated. Like they should be placed before the int main. So let's create some constant values here. I will move this one here. Const 3 horizontal position is gonna be equals to 810. This is just an integer, right? Integer. So I will duplicate this, but this time this is gonna be at 0, so it's gonna be on the top, and this is the vertical one, right? Vertical. Actually, it should be just y and x, but vertical. Okay, position is 0. So then I will set the position of this thing here. So sprite 3 that set position. In this case, I will have a 3 horizontal, comma 3 vertical. So for now, that's what we have. Okay. What else? And then I have to draw. So I will do the same with the bees. So const save texture. So texture B in assets slash textures slash B b.png. So in this case, I will create an SF sprite called sprite B that has a parameter texture B. No, B. Okay. Then I say sprite B that set position. This is gonna be at 0, 800. So it's gonna be 800 units from top to bottom. Now we have we need to create also a variable called related to B, and so a boolean is B alive, is B active, or B active. I do prefer to say is B active, then this is false. Then but they are asking if B is moving, so let's moving instead of active. Is B moving? False. Float speed B speed is gonna be equals to 0.0f. Okay, those are the variables for the B. So we have the texture and we have two different elements for B. I think at some point we are gonna refactor this because I don't like how this is smelling. So now let's do the same for the clouds. For the clouds, I will define constant. So how many clouds are we gonna load? We are gonna load 3 different clouds. So const sf texture this is a texture cloud asset slash textures slash cloud dot png. ¿Listo? Const. Okay, so we are gonna create 3 different sprites. So sf sprite. What was that? sf sprite sprite cloud 1. It has texture cloud. sf sprite sprite cloud 2. It has also the same texture cloud. sf texture no sprite cloud 3 also contains texture cloud. So I have these 3 instances of the sprites. So let's set them all. I would like to do it here. So sprite cloud 1, that's set position. No. Set position. This is gonna be at position 0,0. Then I will just copy this one. I will go here 2, 3. So this last one is 0,500 and this one is 250 and this is cloud 2 and this is cloud 3. So I defined these positions of these 3 different clouds. So also cloud, so there is also a boolean is cloud moving moving equals false. So that's the initial state. I will say the same here. Here is cloud 1, is cloud 2, and then it's cloud 3. And then I will define the speed. So float cloud 1 speed is 0. Copy this. I'm gonna put it here, which is also this one, and here finally. In this case, all of 3 are gonna start with 0 for the speed, and then I will draw them all. So here, after that, I have to draw window dot draw. Dame 5 minutos, porfa. Sprite. Let's begin with the cloud. So cloud 1. Then I will Okay, I will just say do it the same. Then I have to do the 3 and then I have to do the B. So this is 1, this is 2, this is 3, this is the sprite 3, and this is the sprite B. So let's run this. Let's run this, dame un segundo. And this is what we have. We have a B, and we have the 3 clouds. Okay, and we have our 3. So I think we are now ready to leave this setup. So I will press escape to close this. So I will just put it here and just adding B, 3 and clouds to the scene. So I will push this. For now, I think I will just leave it as it is here. I'm just gonna get some lunch. So thanks guys for joining, and I hope to see you tomorrow or maybe later. Bye bye. Thanks.